Folks, remember last time where we learned about solutions and how to make up solution? I still have that solution of nickel 2 nitrate right here. And what I want to do today is I want to learn how to dilute it, to make it even less concentrated, to do it in a quantitative way so we can find out the exact molarity of the new solution. So hence today we want to talk about dilutions. So here we are, podcast 9.5er. And on podcast 9.5er, I still don't have, I can draw, but I can't forward. Dilutions, there we go. Making dilutions. The key to making dilutions, ladies and gentlemen, is an equation. One very simple equation. M1V1 equals M2V2. So if I have a solution in a flask, and I want to take some of that solution out and put it in a different flask, I can transport some of this and fill this up with water, and I can determine the new molarity. Sometimes I'm solving for the new volume, etc. One of the key nice things about this equation is that your molarity, of course, is in molarity, but your volume can be in any unit as long as you're consistent. So if this is in milliliters, then this will be in milliliters. Or if this is in liters, this will be in liters. Or for that matter, this could be in gallons, and this will be in gallons. So it makes no difference what it is. All right, let's do an example. Let's say I have 22.5 milliliters of a 2 molar stock solution. So if I have a stock solution, all right, that's the stuff I start with, and this is 2 molar. And I have 22.5 milliliters, not very much of it. Now I'm going to place it of copper sulfate. It's not important actually what it is. I'm going to place it in a much bigger beaker, and I'm going to fill this up to 250. So I just used my equation. Well, this right here would be a V1. It's a volume, milliliters, right? This would be M1. This number right here would be a V2. So I'm going to do M1, V1. So that would be 2.0 molar, that's M1, times V1, 22.5 milliliters, is equal to M2. That's my variable, my X if you will, times 250 milliliters. Now math's pretty easy. I divide both sides by 250, don't I? So I take my calculator and I divide. All right, I'm back. I had to go away because I didn't have a calculator. All right, well, there's my calculator. 2 times 22.5 divided by 250 gives me 0.18. So that's a 0.18 equals my M2. So it's a 0.18 molar solution of copper sulfate. All right, now we're going to do a different example. In this different example, we're going to take a stock solution. I'm going to draw a picture of this stock solution. And let's say that the stock solution is a 1.2 molar solution. And I want to make up 500 milliliters of a 0.020 molar solution. All right? And so we want to make this up. So to do this, we're going to, of course, use our equation M1V1 equals M2V2. So we're going to try and solve for V1. So M1 is 1.2 molar times V1 is equal to M2. That's this number, the 0.020, 0.020 times 500. So I take both sides, divide by 1.2, so 0.02 times 500. You should do this on your calculators too. It's divided by 1.2 so you know how to do this. And I get V1 to be 8.33. And since this was in milliliters, this will be milliliters as well. So now I want to show you, physically show you, how you would actually make this up. You have to do the math first, but then let's show you how you would make this solution up. Well, guys, here I am coming in, and I'm bringing with me a new solution. This is the 2 molar stock solution of the nickel nitrate. So it's a little more concentrated, hence it's a darker color of green. And so what I want to do is I want to dilute that to 500 milliliters. And so notice I have a second volumetric flask, which is much, much bigger than the other one. And so what I'm going to do is I'm going to fill this volumetric flask up to the line. There's just one line, the 500 milliliter line, but I need to now extract out of the dark green stuff a particular amount. Now if you recall, we did the math on the screen, and the math on the screen says we needed 8.3 milliliters. Now to get 8.3 milliliters, we need to measure this very accurately. So I have brought with me what's called a pipette, or actually a volumetric pipette. It's basically a straw with numbers on it. So now if you zoom in right here, what you can see is you can see many numbers with graduations or lines, and each of these is 1 milliliter, 2 milliliters, and these fractions are fractions of a milliliter. So I need to extract that. Now the technique on this is actually quite tricky. We will use what's called a suction bulb to do this. Okay, let me go off screen for just a second. Okay, I'm back. Sorry, folks. I had to go get my bulb. And so I have this bulb, and this bulb, what I need to do is it's like a, what do you call it? It's a sucky bulb. Although chemistry never sucks. Remember that. Remember that. Everybody say that. Chemistry never sucks. Pushes. Okay. So I put the bulb on here. Now one of the mistakes I see students do is they take it on this and they stick this bulb and they jam it down on top. That's incorrect. What you really want to do is you want to put the bulb and barely put the bulb onto, and I just jammed it on there. I want to just barely get it on there, okay? And then what I'm going to do is I'm going to go to my stock solution. So I have my stock solution right here. And I will take the stock solution, and it won't work because this bulb doesn't fit in here. So what should I probably do you think?
Pour it into something that fits.
I should probably pour it into something that it fits in. So let me find one of those. So as you can see, I have a small beaker. I'm going to pour a little bit of the copper nitrate, or cobalt?
Nickel.
Nickel nitrate, thank you, in here. Now, one thing that I notice here, you can push the bulb, and when you're pushing the bulb, what I'm going to do is I'm going to actually squeeze the bulb, but I'm not just going to let it go. All right. What I'm going to do with the bulb, I'm not going to let it go. See, boom, like that. I'm going to actually just hold on to the bulb, and I'm going to just draw up the liquid into the pipette. I'm not releasing it because what I want to do, I should have this on the ground. All right, now what I'm going to do, actually I want to put this in my left hand. I'm squeezing with my left hand because my right hand, what I'm going to do is I'm going to take my thumb and I'm going to flick it off. This is the 0 line right here. I'm going to go above the 0 line and I'm going to flick the bulb off. So, and put my thumb over the top and squeeze real tight. So now what you can see is I'm squeezing really tightly and the liquid is not changing. So if you look carefully there, it's above the line. The 0 line is about right there. So now what I'm going to do is I'm not going to take my thumb off, although it will flow real fast, is I am going to just release some pressure. I'm going to try and do this without, usually I have my hand over and you can kind of see the liquid going down very slowly. Notice my thumb is not off, it's just releasing the pressure. Boom. Notice also that the bottom of the meniscus is on the 0. Do you see that? Now, I need 8.3 milliliters of this, right? So now I'm going to do is I'm going to put 8.3. Now this is a 10 milliliter pipette. If I needed 10, I could just let go and it'll all go through. However, I need to stop at 8. There's the 8, so it'll be 3 decimal places after that, 8.3. So I'm going to now allow the liquid to draw down. Notice I'm only releasing the pressure. I am not just taking my thumb off. I'm going pretty quickly. This is kind of an acquired skill. You will get better at it as you do this. You will make lots of mistakes at first. Boom, 8.3. So I stopped at 8.3. Notice there's still a little bit of green stuff left over. I'll just put that back in the stock solution. Now I essentially need to fill this flask up to the 500 milliliter mark. So I take the water and I pour it in. You should use distilled water if you're trying to be super accurate. So this is just sort of a demo, so it isn't distilled water. Now when you're about half full, one thing that's good to do is to shake it. Notice it's kind of a lighter green color, notice the 2. But we actually need to make it lighter yet, don't we? And so I'm going to then fill this up to the line with additional water. It's going to be almost yellow, I think, really, when it's all said and done. Now, when you get close to the neck, I usually stop. I might go just a skosh farther. There's a word, skosh. Now, what do I need to do at that point is I want to take a little device. You've seen these before. I want to take the barrel pipette because I want to get it right to the line, and the line's right here. So I'm just going to take the squirt deal. All right. And what happens if people are pouring, they tend to go over the line. It's so easy to go over the line.
What happens if you go over the line?
You start over.
Ah.
And that's no fun. And notice I'm right on the line. I use my cool barrel pipette. The bottom of the meniscus is right on the line. And this is now the more dilute solution. I think it was the 0.02 molar solution of nickel to nitrate. Okay? So that's how you make a dilution. And you will do a dilution lab, where you will figure out how to do all this yourself. And do it yourself, and you'll become Mr. Pipette Expert, and you will learn how to use this. Actually, one thing I did not say. Is this a good idea, Mr. Sams? To suck with my mouth?
No!
Why not?
Because you don't know where it's been.
That's right. And because, actually, if it was like nickel to nitrate, it would cause brain damage. You might think I already have brain damage, and you might be true. But hey, that's your own problem, because I know I'm a good man. All right, we'll see you. Okay? And so we're back on the screen, and that was the 8.3 milliliters. And you can see we made 500 mils, a 0.02 molar solution. And we don't even need to do that. Okay, when you make a dilution, actually, here's the rules of making a dilution. You might want to write these down. Actually, you need to write these down. Use the dilution equation to determine how much you need, V1, that's what we just did. Use a pipette to measure out the exact amount. Put it in a volumetric flask and fill the line, which is what I just did. And I explained a little bit about how to do the whole thing. Okay?
And don't knock it over when you're done.
And Mr. Sams just spilled every last bit of that nickel 2 nitrate. Here's some pictures that help illustrate that. I think you saw it better with the visual, but here are some pictures that you can now look at. Hopefully those make sense to you. This was supposed to be a picture. And so, folks, that's... I'll see you out. Goodbye.